recording?
This phase of the project is funded by a generous grant from the Power and Energy Society, and that's how we bought all this material we're working with today. What you're looking at now is our control center for the photoelectric power system. We have 3 8-volt batteries in series that give us 24 volts for the system voltage, and each battery has a capacity of 160 ampere hours, which is quite a bit of energy. And those are maintained by the charge controller. Maybe if you can back up some, this little black thing down here. That's a maximum power point tracking charge controller. And what it does is, as it turns out, you can most efficiently move energy from one medium to another when the impedance matches. And solar panels, the impedance varies depending on how they're illuminated and the temperature. And so this unit continually manages to find the, be careful of the battery.
Who's that?
This is a comedy video.
This unit continually is checking to see if it can match impedance properly with the panels to get the maximum transfer of energy, which it does by virtue of a computer algorithm. This is our load center over here, where we can switch different sections of our electrical loads, the water pump, the illumination in the greenhouse, and the thermal heat exchanger system control from here.
And it has 4 separate breakers.
Yeah, we have 4 circuits we can operate from this breaker place, and of course these are have built-in circuit protection, so that if any of the circuits should draw excessive current, it'll automatically turn it off at this point.
And the thing that's missing from here is we're working on tomorrow is the inverter.
Power inverter, that's correct. We're going to be adding a power inverter that has about a 300 watt output. That could be 300 watts at 120 volts AC. So you could use small things such as a laptop computer, maybe even some small lighting instruments if you like. It'll also have a couple of 5-volt USB ports on it where you could recharge your cell phone.
So any of the gardeners that need an emergency call and their cell phone's dead, they can charge up their phone.
Mm-hmm.
So what are we using the power for? This system. This is a completely off the grid system.
Right. We're in a position where we don't have any access to grid power. So this is the source of all the energy required for the systems we've been discussing. The water supply over there, for it to get pumped, this will be powered by this system here. The heat exchanging system requires movement of a lot of air through our heat exchangers, and this will be powered by these things as well. It puts out 24 volts DC, so all of the loads we're selecting for lighting, water pumping, and air pumping is going to be a 12-volt system.
Now,
or 24-volt system.
Just if Jay, can you pan up to the solar panels themselves? So when we got these solar panels, I think they didn't have any pigtails. So what did we have to do?
Right. Yeah. The panels came without the customary pigtails that has some universal connectors on the ends of them. So without those connectors, we had to figure out another way to get access to the electrical power. So we opened these little black module boxes here, and we directly connected our wiring scheme into the panel, so that we don't have those convenient connectors, but this actually is probably more efficient wiring scheme.
So they're all in a series. And what is this? There's a separate device on the side here.
You can lower the lid, maybe they can see that better.
Okay, let me just
do that. Oh, sorry. But if you pick this up this way, there you go. You can see an array of 4 cylindrical objects. These are diodes. They only allow electricity to flow in one direction and not the other. And so by connecting our 4 24-volt arrays together through the diodes, it prevents any of the sections that may be less illuminated to start consuming energy rather than supplying it. So that's what the diodes are for. So we take all the 4 arrays of 24-volt generation, and we bring the positive sides in here and combine them into a single wire exiting here. And then all the negative sides of the generators come in here, and it exits on a single wire there. So then we have one individual twin lead that brings all the power into our box for charging batteries and managing loads.
And we're in an open field. What's the risk of a lightning strike? Well, how do we prevent any kind of situation?
We have a We have a grounding system on the solar panels so that the frames are all at ground potential. What that can do for us is that all of the points on the frames can actually bleed charge into the atmosphere and reduce the probability of a lightning strike. If we should get a little bit of a strike, that'll keep the voltage from rising so much that it might damage equipment inside of our box.
So solar panels are a little unique. If they have a surge, are they damaged?
They can be. I mean, they actually have very thin foil that collects the current across the surface of the silicon cells. And so that can be damaged if they have a power surge, but I really don't see that happening. I've been involved with a number of solar panel systems, and I've never seen a panel that damaged that way. It's very rare. The good thing about solar panels is that the amount of current that goes out of a panel is a function of the quantum efficiency. That is the way it converts photons in light into electricity. And because of that, you can directly short circuit the output of any solar system, and it'll never reach a harmful current level. It's intrinsically limited.
So these 480 watt panels are sized up with the size of the controller and the number of batteries, correct?
Actually, the way we do the energy budget, which is why you choose the panels you do, we make some calculations as to how much light exposure will be available throughout the year on the panels. And based on that information, we figure out how much energy we need every day to operate the essential systems around here. And then the panels are sized to be able to provide the amount of energy used in the daytime as well as excess required to charge the battery for the evening use as well. So it's actually an